In this video, I'm going to continue going through the questions from the Math Grade 9 PAT year 2010. All right, as I said in the first video, this is an older PAT. It is from 2010. So that does mean there are some things that may not be relevant to what you guys are learning about now. But it also means that this was made at a time when there was no Math Part A. So I'm going to do my best to predict any questions that you could also find on Part A. But other than that, let's go ahead and let's get started. All right, starting off with number 10 here. So it says if a cube has a surface area of 2.16 meters squared, then which of the following equations represents height? And obviously they're saying that height is h of the cube. So this is a good one, really asking you, do you know about your surface area rules? And do you recognize how 3D objects look when they are obviously not even shown to us? So let's start with the first thing. The first thing is I'm going to attempt to draw a cube here. All right, not bad. I'm sure you guys could probably do better, but we've got a cube, and then we have to know if it's looking at surface area, it's asking us what are the area of all the sides. So I like to think of this as if we are wrapping it up in gift paper. If we're wrapping it up in wrapping paper, it's going to be covered from, top, bottom, all that stuff. So that means we're really accounting for 6 sides. Then we have to think, well, okay, how do we get the surface area? How do we actually calculate it? Well, we start with a square, and that's a 2D square. And we say, well, it's like side times side or length times width. So that means we're going to go length times width or side times side, whatever this number is. And then we're going to have to multiply it for the 6 sides that are on the cube. So what this question is asking us is, can we get the reverse when we are given the entire surface area? Okay, so the first thing I'm going to say is let's do this in reverse. Well, I'll have my 2.16 meters squared. I'm going to want to divide that by 6. That would be the first step I would take if I was doing this question in reverse. Then the second thing is we have to find the side length. Well, we know it's length times width or side times side. Since it's a cube, all the sides are the same. That means I have to do the opposite of multiplying two numbers that are the same. Well, we've seen this before. So for example, if the side was 3 times 3, that would equal 9. And we know if I take the square root of 9, I'm going to get 3. That means the reverse, or finding two numbers that are the same that multiply to something, is to take its square root. Okay, so that's going to leave me with my answer of option A. Sorry, I just realized my head was in the way for this one. So what we're saying is 3 times 3 is equal to 9. And if I take the square root of that 9, I'm going to go back and get the original number. So when I take the square root of whatever the area of this is, I'm going to get the side length. All right, number 11 here. So it says here, an art store is having a sale. The table below shows the regular price and the sale price of several items. Which of the following equations was used to calculate the sale price? Okay, so we've got a few different options here, and we've got 15, 85, 75, 85. So what this is giving me a hint for is it's telling me we need to first find out what is the sale discount. So I really like this question because it involves a few different things from prior math, like percentages from grade 8. So the first thing we're going to do is we're going to figure out, well, okay, what was the sale price between our $5 and $4.25? So I'm going to set that up using ratios. So it's going to look something like this. So we're saying $5 is the original price. That's the total. And that's now equal to $4.25. So to figure out the percentage difference, I'm going to say that the $5 represents my 100%. That's the total value of my original item. And then what we're trying to do is we're trying to solve for the unknown. We want to know what percentage was used to determine the $4.25. Now I've set this up dollar to dollar and then percent to percent. Just to make that clear, I'm actually going to add the percentage symbol so you get my thought process. Now we can do something called cross multiply and divide. That's going to get me the following. So it's going to be 4.25 times 100 is equal to 100, or sorry, is equal to 5x. Okay, once I multiply these two numbers together, I'm just moving the decimal or two place values to the right. That's going to get me 425 is equal to 5x. I want to get x alone, so I'm going to divide both sides by 5. That leaves me with x is equal to 85. Now, that doesn't mean that the discount was 85%. No, that would be quite high. But what it does mean is it means that the $4.25 is 85% of this. So to find the sales price, what we're going to do is we're going to go 100, take away 85. That leaves me with 15%. So that means everything here was discounted by 15%. Now, I did it before I started filming. If you wanted to, or you can pause it here and kind of try it, you can go ahead and say, well, okay, if this is $7 and I add a 15% discount, does it actually equal $5.95? All right, so now that we know that everything was discounted by 15%, that's great. We now need to figure out which equation can actually be used to calculate the sales price. So what I would do then is I would go ahead and put in the sales price and figure out which one would work. So if I go 0.15 and I multiply that by R, my R is $5. That's going to give me 75 cents. So that's probably not going to work, right? So even though it's a 15% discount, just multiplying it by 15% isn't going to give us the sales price. So let's try the next one. 0.85 times that by my regular price of $5. Oh, there's my number. So that one does look good. And you know what I'm going to say? We're going to just try another one to be sure. So we're going to go $7 times 0.85. That's going to get me the next one. So that one looks like our option. We can try C just to be sure, although I'm pretty sure it's D, or sorry, the answer is B. So R, it's going to say R is $5, take away 0.75. Ooh, okay, so that does work. We can see what they did there. And this is why I'm always saying, let's try more than one option. So let's try the next one. So we're going to say R is $7, take away 0.75. Oh, that is not $5.95. So this one is definitely not going to work. And then let's try D just to be super sure. R, we're going to start with our $5 again. Take away 0.85. Okay, that's obviously not going to work. So our answer here for this one is B. All right, number 3, numerical response number 3. Sam draws two polygons that are similar. The first polygon has a perimeter of 6 centimeters and the second polygon has a perimeter of 10. If the shortest side of the polygon has a length of 4, then the corresponding side of the second polygon has a length of blank. All right, so let's set this up with a diagram. I think that's always helpful. So we're going to start with first. And then we're saying it's a polygon, which means it really could be any shape. Like it could be a square, it could be 5-sided, like a pentagon. It could be anything, but I'm going to keep it as a square or a rectangle. Now it says the perimeter of the first one is 16. And the perimeter of the second one is 10. Now it says here the shortest side of the polygon has a length of 4. Okay, well, this is kind of why I was inclined to draw it as a square. Because if we're adding up, when we're talking about perimeter, just as a reminder, perimeter is walking around the edge of the shape. So if my perimeter is 16, that means every time I walk around the shape, all those numbers have to add up to 16. The only way that can happen is if all the sides were 4. Okay, and that's of course like 4 plus 4 is 8, plus 4 is 12, plus another 4 is 16. And I know that is similar to the area, but in this case, I want to be clear, we're talking about the perimeter. Okay, perfect. Then it says the second polygon has a length of blank. But what we do know is the perimeter is also 10. Or sorry, is 10, not also. Okay, so what we need to do is we need to figure out a way to basically determine the scale factor or set up a ratio, and then that can help us figure out the other side. So one thing I do know is that the perimeter for both is given. So they said that perimeter is 10 and 16. So what I'm doing here is I'm actually just going to set up my ratios. So if the 16 is the first one and the 10 is the second one, when I set up the second ratio, I just have to make sure everything corresponds. Really similar to the question we did with the percentages. So that means the 4 is going to correspond with the 16 because we know this 4 makes up 16. And our unknown is going to be here because we don't actually know what that length is. So now I can do the same thing. I can cross multiply and divide. That's going to get me to 40 is equal to 16x. And then I want to get x alone, so I'm going to divide both sides by 16. That's going to get me with the following. So that's going to get me 2.5. So what this means is if this is the perimeter, and these are the lengths, then the length of the second one, this corresponds to the second polygon, has to be 2.5. And that's our answer. All right, number 12, as the majority of you guys might be getting your learners or just got it. So Christy received a speeding ticket for traveling above the posted speed limit. So here's what it says. It says maximum 100, okay? Now we want to know the inequality that relates to the speed. So she got a speeding ticket for traveling above. All right, so the inequality that shows the speed that Christy was traveling at is she was traveling above the 100. So she's traveling right here. S is greater than 100 kilometers. She was traveling at 100, and that's how she got her ticket. All right, number 13. So really interesting question here, in my opinion. There's a few different ways to do it. Of course, I'm going to show you just the way that I think can make most sense, at least to me anyway. So, sorry, we're looking at number 13 here. It says here, the side length of a cube is tripled. If the side length of a cube is tripled, then its surface area of the cube will increase by a factor of blank. So what we can do is we can start with just a cube. And I'm going to say that's x times x. So if the side length of the regular, this is like my regular one before it's tripled, the area would be x squared. But as we talked about in that previous question, the surface area of a cube, once you find the area of one side of one face, you have to multiply that by 6 because a cube has 6 sides. That means the surface area is going to be 6x squared. That's the original. Then it says, well, what would happen if it's tripled? Well, if it's tripled, the side length would now become 3x. And then that area would be 9x squared. But of course, we're going to have to multiply that by 6. So that's going to get me to 54 x squared. And so now what they're saying is this is the original shape and this is the enlarged shape. And we want to know what the factor will be. So we have to figure out the connection between them two, or basically like the ratio between them. So what we're going to do is we're going to take our larger one. We're going to go 54 x squared, and we're going to divide it by 6x squared. That's going to tell us the factor. Well, we've got the same sort of polynomial on the top as the bottom, so that's going to cancel. And then we're just going to go ahead and say, well, what's 54 divided by 6? That's going to be 9. And so that means our factor increased by 9. Number 14. So this is definitely one that would be a mental math part A type question. I think when I was doing the video for part A, I think the first question is very similar to this. So we want to know, what can the expression be simplified to? We are looking at our exponent laws. So we have a number outside the bracket. We're going to rainbow that in, a mini rainbow, if you will, because it's exponent to exponent. So this is going to leave me with 3 to the power of 3 times 2, which is 6, times 2. Remember, there is an invisible 1 here. 3 times 1 is going to be 3. And these two exponents do not have the same base, so we are not able to combine them together. So that's going to leave me with, this is my answer, which is D. All right, number 15 here. So we've got a ladder here, and it says a ladder with equally spaced rungs is shown. There. We want to find out which of the following equations can be used to calculate the distance, D, between each ladder rung. So what I did is I said, okay, well, the total distance in the ladder is represented by the distance between the rungs plus the, not the rings, the rungs, plus the rungs. Okay, so what I'm trying to say is that this entire distance here, the 206, that total comes about, the 206 is made by adding up all these spaces together, which is the distance between the rungs and the rungs themselves, the ones that I numbered here. Now what we have to do is we have to convert this sort of like word equation into variables that we can solve. And when we do solve it, we're going to get it so it equals D. Okay, so I hope that made sense so far. I know that's complicated. Even explaining it took me a bit of time to figure out how I wanted to tell you guys. So let's go back and let's convert these words into numbers. So the total distance, well, we know the total part of the ladder from here to here is 206. Now we know the distance between the rungs is that there are 7. And we know they told us to use D to represent the distance between each ladder rung. So that's going to be represented by 7D. All right, so we've taken care of 2 major parts of this ladder. The second part is we know we have to add each rung because each of these sections are also included in the 206. So altogether, I numbered them. There are 8 of them, and each of them are 10 centimeters thick. So I'm going to say plus 8 times 10. Okay, so now what I need to do is I need to solve for D. And once I do that, I'm going to have my answer. So let's see what we have here. We have 206 is, of course, equal to 7D plus 80. We want to get the letter on its own. So I'm going to minus 80 from both sides. And based on what I'm seeing here, it looks like they didn't even keep it as 80. So I'm going to change it back to what it originally was because it doesn't look like they want us to actually multiply that through. So 8 times 80, I'm going to minus that from both sides. Oh, sorry, I just did it again. I'll rewrite this. So 206 take away 8 times 80 is equal to 7D. So again, we want to get our variable alone. Now it's being multiplied by 7. So I'm going to want to divide both sides by 7. And then that looks like it's going to get me this option here. Let's double check. 206, take away 80. Yep. Divide by 7, and this makes sense because what I did here would cancel those out, leaving me with the distance between each rung left alone. All right, perfect. So that is the answer for number 15. All right, number 16 here. So if the shape shown above is rotated 90 degrees clockwise about the origin, to form quadrilateral P prime, Q prime, R prime, and S prime, then P prime would be located at blank. So, of course, we know that this is just basically indicating the new image. And we use the little apostrophes to indicate that it's the new one. Perfect. Now, the other part of this, and I recognize that I'm obviously using my device to show it, is to show you how you can flip the image in your mind, but also kind of just re-explain what a rotation is, and of course the origin. So the origin is at the center, right there. And then we have our points here. So P, Q, R, S. Now I know, like I was saying earlier, is I know you guys necessarily can't do this in class, but it does act as a good reminder of how this works. Of course, you're going to be expected to do this in your head, or if you are given scrap paper, sometimes that's an option, then you would use scrap paper to kind of do this. But if we're rotating it 90 degrees clockwise, there's my 90 degrees, and I'm rotating it clockwise, so it is turning in this direction. And the key thing with this is when it says it's about the origin, notice how I have my giant dot right here. That's my origin. Right now, my origin is not lined up with the origin, so I have to move that in place. And that is my new polygon, which I'm realizing now I didn't draw lines on it. So let me quickly do that. Perfect. Okay, so then it says P prime would be located, of course, here. That's P prime. It's in blue for me. And that's going to be at 0, 5, which is going to be answer B. Okay, numerical response number 4 here. When a square piece of paper is folded in half, the resulting figure has a perimeter of 24 centimeters. The area of the square piece of paper before it's folded is blank. So I'm going to do my absolute best to explain this using diagrams and then go into the math, because I know sometimes we get algebra, we get it really well, but applying it to a problem like this gets tricky. And if you haven't noticed, this PAT loves things with area and perimeter, right? There's already been a few questions of those. So, okay, we're trying to find the area. The key thing I do want to point out is it's a square. So we do know with a square, all the sides are the same. And if you didn't know that by now, I'm hoping you know it like right now. Anyway, what we do know is that the perimeter is 24. So if I add up all these sides, you know what, maybe I'll just highlight it so that doesn't get confusing. If I add up all the sides, I am going to get 24. Now, what we know is this is the folded piece of paper, right? This is my paper folded in half. What happens when I open it when I open it entirely? When I open it, I'm gonna get this. So in this scenario, the length should be the same, and the width would have to be double. Okay, and that's because, of course, if this is gone, that's half of my my paper. Okay, so now I can set up something that relates back to my equation. So the first thing we know is that in order to find perimeter, I'm going to go 2 length plus 2 width is equal to, in this case, 24. Okay, easy. We're good for that. Now it's a square. So what this means is that when it's unfolded, this side and this side would be the same. And I'm sorry I didn't draw it properly. I should have really used graph paper. But just remember that it's a square. It's highlighted here and here. So that means instead of using L and W to represent my letters, I actually can use X. So X plus X equals 24. Now the key thing is the 24 only applies to this because that's what was folded in half. So that means I have to tweak a few different things here. It means that while the length is going to stay the same, so this value here is going to stay the same, my width is actually half of the original width, right? Because when I folded it in half, I got rid of this and I got half of it. That means my formula now looks something like this: 2x plus 2x over 2 is equal to 24. Okay, so from there, what I can do is I can solve for x. And I'm gonna hide myself out of the way. There we go. So that is gonna go away, leaving me with 2x plus x equals 24. I have two variables that are the same, so I can add those together. That's gonna get me to 3x is equal to 24. Divide both sides by 3, x is equal to 8. All right, perfect. So if x equals 8, what that means is that this is 8 and that this is 8. Now, since again, we know it's a square and we have to figure out the area, area is length times width. So 8 times 8 will get us to 64. So that is the area for this one. Number 17 here. So we have a weightlifter adds a certain number of equally weighted plates to the barbell. That's key. Shown below, sorry. The weighted plates are identical to one another. So we know for sure that there is an equal amount of plates added on each side, okay? So we got to keep that in mind. Like I said, it's important. If the total mass of the barbell and plates equal 60 kilograms, and if each side of the barbell has the same number of plates, then one weighted plate could have weighed a mass of, and we have to figure it out. So the way I'm going to set this up first is I'm going to say, well, x is just the weight of plates, not the weight of one plate, but the weight of the whole thing. So x plus the barbell, 24, is equal to 60 kilograms. Then, of course, I can minus 24 from both sides. And what this tells me is the added weight was 36 kilograms. That's the added weight. That's not our answer. So I want to make that very clear. That's the added weight, not our answer, which means it is definitely not going to be A. And of course, we've seen this with PATs. They like to put it the most like common answer that they think you all will mess up on, but you're not because you're studying for these PATs. You're watching me right now. They often put that as A when of course it's not, right? So what we need to now know is, okay, well, which one of these would be distributed equally on this barbell, okay? So what we're gonna say is let's divide each of those numbers by, let's divide 36 by each of the options they give us. So 36 divided by 12 is gonna get me to 3. That means there would be 3 plates. That wouldn't work because again, it's equal. So that's not an option. 36 divided by 6, that does work. That's gonna tell me that there are 6 plates. That is a good option. 36 divided by 4 is gonna get me to 9. Again, that's not even, so that's not gonna work. So that's definitely not an option. So our answer for this one is C. All right, so we have definitely talked similar about a question like this and how to set it up. So I'm gonna read it out loud and then we'll go through it. Mark has a certain number of coins that are dimes and quarters. Which of the following expression represents the value of Mark's money in cents? So it's talking about value. It wants it in cents. That's our key word here, right? So we know that dimes are going to be this, which is as a value in cents. We actually just can write that as 10C. Yeah, they're not asking for a value in dollars. So in that previous question where I wrote like 0.25 for the dollar amount for the quarters, here, I'll show you what I mean. So this one is quarters. This one is 25 cents. So because they're asking for the value in cents, not dollars, I don't need to write it as 0.25 as I did in that previous question. I think that was in part 1. So now what they're saying is they have a certain number of coins and which of the following would be that expression. So for that, we know we're looking for the 25 and the 10. So we're not going to combine them because each of these values, the 10 cents is connected to the dimes, like each dime is worth 10 cents. And same thing with the quarters. So the only option that's going to work for this is A, as we're not going to be able to combine them for their value. And same thing with this. And this would be great if it was just asking for the number of coins, keeping in mind if this one worked, we probably would need that number of coins. So that's our answer. All right, number 19. So we want to know which row correctly describes the degree, the coefficient, constant term in the expression. So this is one of those ones where I say, like, let's not even worry about the chart right now. Let's focus on what is going on right here. So the first thing is I see an exponent. That is going to be our degree. A degree is the highest exponent a polynomial can have. Perfect. The second thing is it wants to know a coefficient. Well, a coefficient is the number times a variable. In this case, the only number times the variable is this. So that's our coefficient. And then the constant term, it's kind of like the lonely number. It's the number without an exponent, without a variable. So in this case, it's going to be 4. We are going to include the negative 4 in that. So that leaves us with option A as our answer. All right, so just as in part 1, what I'm going to do is show you the YouTube video I made previously that covers the question for numerical response number 5 in this PAT. Okay, let's look at this example here, numerical response number 5. So this is one of the ones that we really need to be clear about those rules for circle geometry, okay? Otherwise you might look at this and be like, what's going on? So let's take a look at the question. If O is the center of the circle, the measurement of X is blank. So not a whole lot of information. We have our circle. We know the measurement of the circle at the center is 70. And then we're trying to figure out X. So if you don't know the rule for this one, it is going to be a little bit tricky. So the rule for this one is we have to recognize we have our central angle, which is 70. And then we have two chords that come together to make what's called an inscribed angle. So the rule of an inscribed angle is it is half the central angle. Or you can also say the opposite. You can say the central angle is double the inscribed angle. So then in this case, once you know the rule, it becomes a little bit easier. Well, if this angle is 70 and the inscribed angle is half, we have to find out what half of 70 is. Well, half of 70 is going to be 35. So that tells us that X is 35. All right, number 20, we want to know which of the following diagrams illustrate a 90 degrees rotation of this triangle here. So what I did is I actually went in and highlighted all of them. Remember, the original is the one that doesn't have the apostrophes because the apostrophes are prime and would represent the new image. So we're not going to worry about that. The other thing I have to be clear about is our our counterclockwise. So counterclockwise, if you're thinking of a clock, and again, I know some of you don't always know how to read an analog clock, but you know the order of the numbers, at least I'm hoping you do. So then the counterclockwise is going the opposite. Essentially, it's turning to the left. So what we want to do is say which one of these represents turning to the left 90 degrees. So I'm going to do my thing that I was doing before. Oh, I think it was over the origin, right? Yes. So I did not, so I'll do it now. I'm going to highlight the origin, which again is just the center of the Cartesian plane. And then I'm going to rotate this 90 degrees. And when I do that, I always want to line up my origin. If I don't line up my origin, then of course, my shape is not in the right spot. Ooh, I think I just found it. I think it might be C. Let's keep going. Okay, so all of those have been rotated 90 degrees, what is interesting is it does look like this could be an option, but I'm actually going to show you that back. In the original diagram, it looked like this. So there's my origin and my triangle. When I rotate it 90 degrees, there's my turn. Just one turn is 90 degrees, and I line up the origin again. It's really close, but not quite. That is really sneaky. So the answer that I got for this one, the only one that matches up is C. I'll move it away and you can see like there's the original part of the question, and there's the new one. So that is our answer for this one. Okay, so lovely polynomial question. Now I have a sneaky suspicion, this is just me. I feel like this could be a part A question for the PAT. The part that I think would be tricky, and they've done this before, is how you would enter it. So would you just enter the coefficients? Would you enter the degrees? I'm not sure, but I think it's something to consider that a question like this that's polynomial based, because it's not huge, like it's not calculator math heavy, I do see it being as a good candidate for one of those questions. But okay, let's figure out what's going on here. They said when this is subtracted from the sum of this, what is the result? So they worded that really tricky. So we have to keep in mind, we have to add this up together first and then subtract it from this. So when I'm adding polynomials, I do have a whole video series on polynomials, but of course I'm gonna go through it here with you. I'm gonna add them up together. So 5x squared minus 8x plus 2, and I'm adding that with 2x squared minus 3x minus 7. Now, one of the things that I do is I like to line them up really similar to how we used to add numbers when we were in elementary. Like if I said 524 plus 4, I'll give you guys the little laugh. If you add those up, you're gonna add the ones together first, the tens and the hundreds. Really similar situation here. It's just in this time, it's slightly different numbers. So to represent that, what I'm going to do is I'm actually just going to draw lines to show you what I mean and just to make it super clear. So we have 2 plus -7, 2 plus -7. I have 7 more negative things and I'm adding 2 positive things. That's going to change my answer to -5. Notice how I bring down that negative, right? That way I don't lose track of it. I have -8 things and I'm adding it to -3 things. Imagine if you were a tile person, like not tiles like bathroom tiles, but tiles like math tiles. I have red 8 tiles and I'm adding another red 3 tiles. That's going to get me -11x. And finally, with these two, I have 5x squares and I'm adding it to 2x squared. That's going to get me 7x squared. Perfect. So this right here is my answer for the sum of what I have in brackets there. So that sum has to be subtracted with this. So again, I'm going to line up my like terms. Okay. And I'll draw the highlighting lines in. Perfect. So now we're going to go ahead and subtract it or take away. So I'm saying -5 take away -4. The trick with this, which I've seen teachers use, and I actually show it on my integer video, is what we can do is we can pretend we're adding. The only way that works is if we change the signs of everything in the second part that we're subtracting. So now I can just consider it adding. So -5 plus +4. So I have -5 things and I'm adding 4 positive things. That's going to leave me with a -1. -11 plus -9 is going to leave me with -2 things. And then the last one is 7 plus -1. That's going to leave me with -x squared. Or sorry, positive 6x squared. All right, so that looks like my final answer, which is going to be right here. Option C. All right, number 22. So in estimating, in estimating the square root of 70, which two perfect square numbers provide the best two benchmarks to estimate your answer? Okay, well, we've got root 70. Really, what this is asking you is, do you remember your perfect squares? Well, what I do know is I know the square root of 64 is going to be before, and then that's 8 times 8. Then the one above that would be 9 times 9, which is the square root of 81. So my answer for this would be D. All right, numerical response number 6. I would say this is a really sneaky question, okay? So it says here, Darren joins the rectangular prism shown below to create a new rectangular prism that has the greatest possible surface area. That's really important, okay? Keep that in mind. He then paints all visible surfaces. After the paint dries, Darren separates the two prisms, which kind of makes me wonder why would you join them in the first place, but I guess that's Darren for you. So we want to know the total area of both prisms that are not painted. Okay, so really important, of course, to read that carefully, annotate it if you can on the exam. Then let's think about what's happening. I have two rectangular prisms and I'm going to combine them together, and it just wants to know the area that's not painted, meaning the two areas that were together when they were joined. And we know that he joined it to get the greatest possible surface area. So the only way that those could have been connected together is if they put together the smallest parts of the rectangular prism together. So if these two connected and were sitting side by side each other, those would be the smallest parts. And then that would leave the remaining parts, these longer sides that are 10 centimeters high or long, they would add for the biggest surface area. So what it's really asking then is to figure out the area that hasn't been painted. Now, the funny part of this question is I'm highlighting it as if it was painted. Just think the reverse. So this area would be 12 and this area would be 12. Remember, area of a rectangle is length times width. So 3 times 4 is 12. There's two of them that were pressed against each other and then now are opened and they wouldn't be painted. I guess in this case, maybe we'll pretend that the paint was white and the lilac was the original color. So since those two were together, that's going to be a total of 24 centimeters squared. All right, number 23. So the diagram represents a balanced mobile, or mobile. You guys let me know. And it's balanced. So the key thing with this, it's relating to mathematical equations and expressions. And that, of course, if two things are balanced, then they're probably representing the same thing. The tricky part about this is it kind of at first glance feels really random that they went, this is x squared and this is 3x. Like they kind of just came up with something out of nowhere. Where it really relates to is this definition here. So it's asking you to really identify what's a polygon and what's a non-polygon, then apply it to a more complex question. So essentially any non-polygon is x squared, and any polygon is going to be 3x. A polygon is a shape made out of like straight lines. That's how I like to think of it, just super simple. And so now we can add up these parts together. Well, these two, of course, would become 2x squared plus 1, 2, 3, 4 times 3 is 12x. And sorry, let me just clarify how I got that. X squared plus x squared is 2x squared. And then if each of these are worth 3, I'm timesing them by the 4 that are there. 3 times 4 is 12. It's got an x on there, so it's going to be 12x, giving us our answer of A. Okay, number 24. So which of the following equations is equivalent to the equation shown above? So really, this is kind of just asking you, do you understand your number sense? Do you understand things like place values? First thing I notice is I'm looking at this number here, the 2.15x, and then all of these options. The main difference between the one on top and the one in the options is that we've moved the decimal 2 spots over. So essentially we've multiplied it by 100. So 1, 2. What that means is if I did that to obviously one part of the equation, I have to do it for the whole part. So 1, 2, and 1, 2. Now in those numbers that are just empty, I'm going to place a 0 in them. And notice how like that means my decimal is moving to the end. I'll actually draw it at the end of my movement. So now I'm looking for 215x, I forgot the x the first time, plus 780 is equal to 2,500. Well, and there it is, right there. My answer for this is going to be A. All right, so in this question it says, the diagram below shows the front elevation of a building on a blueprint. And so we can see here that we've got our window, our door, and most importantly, our blueprint scale. So the blueprint scale indicates that 1 centimeter on the blueprint is equal to 18 meters in real life. Okay, and the reason I know that is because they told me right here. They said it's to the meter. The other part that I want to be clear is when we have to find it. So it says here, based on the diagram, based on the dimensions shown on the blueprint, the actual dimensions of the window to the nearest meter would be that. So what I need to do is, if I'm looking at the dimensions, I want to multiply this number by 18, and same thing with this number. So when I do that, I'm going to get 176.4. And when I do this, I'm going to get 108. Oh, sorry, I'm just realizing that it wouldn't be meters, it would be centimeters because it's a 1-to-1 ratio. So then we would have to convert that. Sorry, we would have to convert that, and we'd have to convert the centimeters to meters. So when I do that, I'm going to want to divide both of them by 100. The reason I'm dividing is because 1 meter is equal to 100 centimeters. When I do that, the closest to the nearest meter I'm going to get is this would be 1.8 meters. I'm just moving the decimal, really similar to the previous question. I'm just moving the decimal back. And then same thing with this one. So this one would get rounded to 1.1 meters. So my answer for this is going to be C. Okay, so we have number 26 here. It's a survey question. So it's basically trying to say, do you recognize how a survey is worded, and is that the best way to word it? So the question says, the following survey question was given to a sample of grade 9 students. Do you prefer to use your television to play childish video games or to watch educational programs? So of course, they're kind of priming you with that wording. If you are labeling something as childish, people are less likely to pick that, especially if they're asking, teenagers this, right? A teenager, you guys are teenagers, you don't really want to be known as childish. Or do you want to be smart and watch educational programs like the YouTube video you're watching right now? So of course, the issue with this one is the use of language, right? It's not, it's going to sway people to choose one over the other. All right, number 27, Jim simplifies the expression as shown below, and they want to know which step did Jim make an error. So the first thing I'm going to do is we're going to ignore all the steps, because sometimes we can get influenced by what we're seeing there. So instead, what we're going to do is we're going to say, okay, well, let's just try and solve this on our own. In fact, even this I'd probably ignore, but let's see. So the first thing I know I have to do is rainbow this in. And I am going to rainbow in the negative just to get rid of that. So that would give me 5x plus 10 minus 8. Oh, there it is. Negative times negative should make a positive. So that actually was pretty good. I didn't expect to find the mistake in step 1. So the answer for this one is step 1. Okay, number 28. Tim buys 2 kilograms of almonds at $5.49 per kilograms and 4 kilograms of cashews at a store that includes GST in its prices. If the cost of his purchase is $25.50, then the price of 1 kilogram of cashews is blank. I'm really sorry if you're allergic to nuts. That's an annoying question to read sometimes. If you're allergic to that, you might have like a strong dissociation to it. Anyway, so what I did is I said he bought 2 bags and each one was $5.49. So we're going to have to double that. I'm listing X as the cashews, and we know that they get 4 kilograms of it. The store includes GST. All that is trying to say is we don't have to worry about it. So the final price includes GST. And then the total cost was $25.50. So what we need to do is actually just solve this. So 2 times $5.49 is going to be $10.98 plus 4x is equal to the final price. And then I'm going to minus that from both sides because our goal is to get x alone. X representing the number of cashews. And then we can divide both sides by 4. So x is equal to $3.63. So our option is A. All right, number 29. Sandy has a budget of $100 to spend on back to school clothes. The shirts she wants to buy are $12 each. So I wrote that over here. And the pants she wants to buy are $25 each. All prices include tax. So again, that just means we don't have to worry about that. Which of the following inequalities could be used to determine the maximum number of shirts and Sandy can buy if she also wants to buy 2 pairs of pants? That's key, because if you don't see that, you are actually going to pick the wrong equation. So it's an inequality. We know her budget is $100. That means she cannot go over 100. She can spend 100, which is why all of these include the line at the bottom. She can spend $100, but she cannot spend more than that. So already right off the bat, that tells me I can get rid of this and this because she can spend less than $100 or exactly $100, but not more. Perfect. Now we know for the number of shirts that she wants to buy, it's going to be $12. So that's taken care of. And then we know the pants, she is buying 2 sets. So that's going to be, or 2 pairs. So that's going to be multiplied by 2. All we now have to really think about is, are we adding this to her total budget or are we subtracting it? Sorry, I said that the other way around, right? So A says that we're going to subtract it. Well, that doesn't make sense. She's buying these, so she's putting them in her cart, right? Digital, or I guess like a little basket when you go shopping. So that means A wouldn't be an option at all because you wouldn't be removing those items. So our answer is going to be B. All right, last one for this video. That means there is going to be a part 3. It's just really long, so it's what it is. Alan, Bob, and Charles worked together on a job and earned a combined total of $380. Alan earned $40 less than Bob. Charles earned twice as much as Alan. Now, this is one of those questions that I think is fair game because what they're asking you to do is to come up with an equation based on the info and then solve it. So the first thing I know is that if I go Alan plus Bob plus Charles, that's going to equal a total of 380. Now we have to go ahead and add those different variables in. So we know that Alan earned $40 less than Bob. So in that case, I'm going to say that Alan is going to be X, whatever the money was, take away 40. I'm going to put that in brackets because that just represents Alan. Bob is Bob. We'll just leave Bob alone because we don't have anything that says it's more or less. And then we know that Charles was twice as much. So that's going to be twice as much as Alan. Well, we said Alan is X minus 40. So twice as much would be 2 times X minus 40. Now I kept B as B just so you could see what's happening. But what I need to do is I actually need to change the letter B for our variable X. Okay, X is going to ultimately determine Alan's own because everything is compared to that. So now I can actually start to solve this. So I'm going to have X minus 40 plus X plus 2X minus 80. I'm going to bring this down. So if I combine my X's here, that's going to get me a total of 4X minus 120. Oh, and I forgot my equal sign. Sorry about that. Is equal to 380. I can get 4X alone. by minusing 120 on both sides. So 4x is equal to, sorry, by adding 120 on both sides, 4x is equal to 500. Divide both sides by 4. So x is equal to 125. But, okay, wait, hold on. X is 125. X, we said, was Bob. The question is not asking about Bob. It wants to know about Alan. So if Alan is represented by x minus 40, we're going to have to go ahead and say Alan is equal to x minus 40, which is 125 minus 40. Perfect. I guess, yeah, that's right. Sorry, I'm getting tired. This is why this video is going to need a third part. So then that means Alan earned $85. Okay, I hope that was helpful. We are about a third way through all the questions, probably a little bit more. So join me for part 3, where we finish this entire PAT.